Okay, the last video for the kind of the tutorial part of all this is basically just, it's called, well, there's two slides. One is on density, and that's letter F. And there's not much to say about that. I hope you've all been density to death throughout elementary, middle, and high school. But what it really means is, for us, does it feel heavy for its size? And if it does, if it's heavy for its size, that means the atoms within that sample are very tightly compact, and it just feels more heavy for that reason, because you're cramming more matter into a smaller space. So here's just an example. I've got galena here, which is a beautifully shiny metallic mineral in luster. And it also has a cleavage pattern, by the way, which you can see a lot of 90-degree corners in there. That is a breakage pattern associated with this, that when they smash it, you're going to get these little, it's kind of similar to halite where you'll get cubic shapes. But this is talc, not much exciting about it. It is an ingredient, an old ingredient in baby powder in the old days. But really what you're going to have to take my word for this, is that this little nugget right here, the galena sample, is actually heavier than this, the talc. So something this small, comparatively side by side, is heavier than this. And that has to do with density. And so if you were to hold these side by side, you could feel that for yourselves. Unfortunately, virtually, you're just gonna have to take my word for it. But you know what I mean. What if this were a piece of styrofoam and this were, a rock, like metal? You would notice the difference, even though one could be much, much larger. So similarly, like a basketball may not be as, or may be lighter than, say, a softball. I don't know. So similar to that. Okay. So a couple of other properties on the next slide. This just says slide G here, or it's letter G. It's just other mineral properties. One is visible crystal structure, and we've talked a lot about that already, how quartz will grow in a crystal pattern as it forms, and that's what you see. You see a kind of a hexagonal shape, and you'll see, if you looked at a lot of different samples in the area where you got this one from, you'd see a lot of them have that same shape. And you'll see smooth flat sides. Again, that is not cleavage, because when you break it, it looks rough and ugly like that. But that's a pattern, and you'll see a lot of quartz crystals that look exactly like this in different parts of the world. Same goes for this guy right here. This looks like a lug nut almost from your car. This is a segment, a broken or sawed off segment of a corundum. And this is one of the hardest minerals besides diamond that we have on Earth. And you can see, if you look at it, it looks like a hexagonal bolt almost, or nut rather, and looks like you put a wrench on there and just turn it. And that is repeated throughout many of these samples as well, and that's visible crystal structure. The next one on that list is fluorescence, and I don't have an ultraviolet light, so I can't show you fluorescence, but if you put a UV light up to certain minerals, you'll see them glow certain colors. So I invite you to click that little link next to number 2 there on fluorescence, and you'll get to see lots of different minerals that do that. It's pretty cool, and it's a natural phenomenon that happens due to the interaction with ultraviolet radiation. This one I can show you, effervescence. So like I said, I think back in the intro slide on carbonates, this happens in certain minerals that are made up of certain things, and they react with acids. And I mean, simply fruit juice in some cases could do it. I've got some very, very weak hydrochloric acid here, and I'm just going to put a drop on here, and we're going to see what happens. Hopefully you can hear that a little bit. It's fizzing, and you can certainly see the bubbles forming, and that is a reaction, and that's carbon dioxide gas being given off due to this mineral being exposed to acid. And so we learned that the hard way when they were using certain minerals in gravestones, and over 50, 100, 200 years, the gravestones would get slowly worn away due to acid rain and stuff like that. So yeah, so that's effervescence. It's kind of like Alka-Seltzer, basically. The other one would be odor or taste. I think I can have you guess what this might be. This is a chunk of sulfur, and I can tell you I can smell it from here. That has a very distinct odor to it, and it, also, if you've ever smelled that and water from some places in Texas, that is because they have sulfur water, and that sulfur is dissolved in the water, which makes it have that same exact sulfur odor, which is highly unpleasant for most people. Greasiness. Greasiness is an interesting term that basically happens with really soft minerals. This is talc again. If you feel it, it's almost going to feel smooth, even though it's rough. When you look at it, it feels smooth because it's so soft that it absorbs the oil from your fingers, and it actually creates like a very kind of a slippery, very minuscule layer of oil between your skin, between the pores of your skin and whatever, and also on the crevices of the mineral. So that feels very oddly smooth, and that happens with graphite and other really, really soft minerals. Then we have the last one, kind of interesting. It's magnetism. I've got a paper clip here. I've got a sample of magnetite, and if I do that all on its own, like magic, it'll attach. So, and you can see it almost spun right there a little bit because there's a certain magnetic field there, and that has to do with the fact that magnetite has a lot of iron in it and was specifically polarized wherever it formed based on the Earth's magnetic field. So when you have a lot of iron in something and it becomes permanently magnetized, you can get that kind of a phenomenon. So that's pretty neat. And magnetite is one of the few minerals that shows magnetic properties, and you'll find that that is true whenever there's a lot of iron in a mineral. And that's it. Those are some just random other things about minerals that I thought you'd like to know and can help you identify them. And we'll talk about how we do that in the next segment.